Hello folks, we come back with the next problem number 10 of this exercise 7.6, and here is the problem that's there on the board. It says that it is sine inverse x the whole squared. So as such, we don't find any product. All this time we used to have product of terms, and that's how we used to do the problems. Now here there's no product of terms, so it is sufficiently confusing as to how we will work with this. So at this step, I think we'll have to go in for a substitution, so that you can convert this thing as a product and then use integration by parts. So for that, let's have a substitution done. Let maybe t be sine inverse x. So if t is sine inverse x, dt is going to be sine inverse x, we know, or rather we could write x as sine t, because we'll require it both ways. Then it's easier. Dx will be cos t dt. That's more easier. Also, we'll require some more conversions. That as time comes, we will do it. So let's now come back to I. I is sine inverse x, which is t squared, and dx is there. So dx will become cos t dt. Now we can apply the integration by parts here. This is algebraic and this is trigonometric. With ILATE, we will come to know that algebraic comes first, then comes trigonometric. So let's write u as t squared and let's write v as cos t. So you get du over dt as 2t, and you get integral v dt as minus sine t. Sorry, as sine t. So your integration becomes u integral v dt, because t is the derivative, the variable here, minus du over dt integral v dt whole dt. Let's quickly make all the substitutions and see how you're going to get the thing. I now becomes, u for us is t squared v dt integral v dt sine t minus du over dt, that is 2t, and integral v dt sine t dt. So this becomes t squared sine t minus 2 outside t sine t dt. Now t sine t we have done in the problem number 1 actually. So from there directly let's write. I will write the result here. X sine x, we have done it. X sine x, we wrote it as minus x cos x plus sine x plus c. Let me see. Minus x cos x plus sine x plus c. That was how we did the integral in problem number 1 itself. So that way we can do the substitution directly. So therefore this will be t squared sine t. Otherwise in this problem, when we have to take it as I1 and apply the integration by parts once again and get the integral. So here it is 2, since we have done it just some time back, so we can take it. But in the exam, of course, you will have to do it once again and show. T cos t plus sine t plus c. So let's write this. T squared sine t plus 2t cos t minus 2 sine t plus c. Till here it's okay. But now reverting back is a big problem, because we have got because we've got all these t's, and we know things only in x. So let's getting back, okay. So t for us is sine inverse x. So this is sine inverse x whole square. Sine t is x. So luckily this part is over. Now next part is 2t. So t for us is sine inverse x. This is challenging. Cos t. We don't have anything like cos t here. So let's take it from here. See, we know that cos t is root of 1 minus sine squared t by identity. So that way it will be 1 minus root of x squared. So let's take it like that. Sine inverse of x, root of 1 minus x squared, minus 2 sine t they say. That means minus 2x plus c. So we've got everything in terms of x, since we had t was our assumption variable, so we had to get it back. So I will just quickly check if everything is right. Perfect. So that's all about this problem. This is how we do. Of course, this step I have written directly, and that's because we had the problem number 1 done just some videos back. So we can just refer from there and do, but in the exam we have to treat that as I1 and solve it once again and then incorporate it back into the problem. So that's how it has to be done. So that's about this. So that's all for the work to be done. With more problems, we meet in the next video. And as I always tell, please popularize the channel. See that there are so many people sharing it, and then we have more subscribers subscribing the channel, and that's how we are amongst people there. Thank you.